Today we'll be discussing mixed numbers and how to add them with like denominators. Mixed numbers, if you recall, is a number that has both a fraction and a whole number. For instance, 2 and 2/3 is a mixed number. Here we have both a whole number and a fraction. They are mixed. That's why we call them mixed numbers. Sometimes when we add fractions together, such as these two fractions, we end up with an improper fraction. When we fix this fraction, we call that regrouping. Today, when we are adding some of these mixed numbers with like denominators, we might find that we will end up with improper fractions. That happens quite frequently, and we'll need to regroup. In other words, change this improper to a proper fraction. It helps to do this by reading this fraction as a division problem. What this really is 4 divided by 3. Or how many times does 3 go into 4? 3 goes into 4 one time. What would be left over would be 1. And we would make that our numerator, and our denominator would stay the same. So it would be 1 1/3. This is what we call regrouping. So let's take a look at how we might add two mixed numbers with like denominators. When you see a problem like this, what I would refer to as lying down, and it's written in a horizontal fashion, the very first thing you need to do is rewrite this problem, standing on end. There's a very good reason for this. It's not advantageous for us to do this when the denominators are the same as they are here, but when they are different, as you recall, when learning how to compare fractions, we're going to need to create new fractions with the same denominator. So it's a good idea to get into this habit now. When adding and subtracting fractions, always rewrite them standing on top of each other. With this problem, we're simply going to start on the right-hand side as we would do with any normal non-fraction addition problem. We're going to start by adding 2/3 plus 2/3. The first thing you want to look at is the denominators. If the denominators are the same, then you may proceed. If they are not the same, then you must create new fractions with the same denominator. Today we're only going to deal with denominators that are the same. So here we are free to add, and when we are adding fractions, we are never adding the denominators. The denominators, if you recall, is the number that tells you how many pieces the pizza is cut into, or any object is cut into, or how many pieces does it take to make the entire object. Well, we cannot change that number, so all we can do is change how many pieces we have. So we're looking at the numerator to see how many pieces we have, and this is what we are adding. 2 plus 2, which equals 4. The denominator, as said before, stays the same. Then we go to the whole numbers and add them. 1 plus 1 is 2. It really is that easy. There are a list of steps here on the right-hand side, and I'm leaving out the last step, which is regrouping. Regrouping is something you need to do after you solve any fraction problem, whether you're adding, subtracting, multiplying, or dividing. Always check to see if you can regroup. In this case, regrouping usually only happens when you're multiplying or adding. When subtracting, you might need to simplify a problem, which is a little bit different. Regrouping is when you have an improper fraction in your sum. And in this case, we do. We have 4/3, which is improper because it only takes 3 to make a whole, yet you have 4. So again, we want to visualize this as a division problem. 4 divided by 3. 3 goes into 4 one time, so 4/3 is going to be equal to 1, and what is left over is 1, so that becomes your numerator, and the denominator will always stay the same. So really, 4/3 is the same as 1 1/3. So in this case, we need to change 4/3 to 1 1/3. That will get rid of the 4/3. And then we have to understand and not forget that we have a whole number 2 here, and we've just changed our fraction to a mixed number. That means it has a whole number as well. So we need to add our whole number to our new whole number. That's 2 plus 1, and that will get us a total of 3. The fraction 1/3 will stay the same, but we're going to combine our two whole numbers and make it 3 1/3. This is the more correct answer. 2 4/3 is technically correct, but we like to simplify things and make them as easy as possible. So we need to get in the habit of regrouping everything. Please take a moment and write down the 5 steps to adding mixed numbers in your math notes. In this next example, I'm going to give you a visual representation of what it is that we're doing here. Our first problem will be 4 2/5 plus 1 4/5. Looking at this visually, after drawing a visual depiction of this problem, we can see here that we have 1 hole, 2 holes, 3 holes, 4 holes, and 1/2 of a hole, all represented with fraction bars. Over here we have 1 hole and 4/5 of a hole representing our other number. If we want to add this up just using our graphics, we can see that we have 1, 2, 3, 4, 5 holes, but we can also see that if we were to combine our two fractions, we could create another hole. So the question becomes, how many fifths would we need to take from this fraction bar to add to this fraction bar to create another hole? How many fifths would that take? It would take 1/5. So if we took a fifth from this fraction bar and added it to this fraction bar, we now can see that we have another hole. Now when we add up our holes, we can see that we have 1, 2, 3, 4, 5, and 6 holes now. And the fraction that's left over is just 1 out of 5. That fraction is down here now. So a total of 6 1/5. This is the way you could do this if you wanted to draw pictures. However, most of the time you're not going to want to do that, as it does take longer and it's not quite as easy to do when you have larger numbers. So going back to the first method, the first step asks you to rewrite your problem standing up. The second step is to check for common denominators. In today's lesson, they will all be the same. The third step is to add your fractions. And remembering that we are only adding the pieces we have. We're not adding how many it takes to make a whole. That cannot be changed. So 2 plus 4 is 6. Denominator will stay the same. Next step is to then add our whole numbers. And the final step, step 5, is to check to see if you need to regroup. And the way to do that is you check your fraction and ask yourself a simple question. If it takes 5 to make a whole, do I have more than one whole? And the answer to this question is yes, you do, because you have 6 pieces, which means you have at least one whole plus a little extra. So if you're looking at this fraction as a division problem, 6 divided by 5, the way I ask it is, how many times will 5 go into 6? 5 goes into 6 one time, and how many then would be left over? There's 1 left over, and the denominator then will always remain the same. Now, we have to remember that we have changed this fraction improper fraction here to a proper mixed number, but we've added a whole number, the number 1. So we have to remember to add that to our 5, to our other whole number. These two numbers must be added together. 5 plus 1 is 6. And the fraction, 1/5, will stay the same. So 6 and 1/5. And we can see that it is exactly the same as what we got when we used pictures to do it. So now we have two methods to do it. And the one I highly recommend is the one where you're using digits, not pictures. On the next slide, I'm going to give you some problems to practice on. You may use your math notes composition book to write these down in. It would be a good idea to have them there with your notes. On this slide, I'd like you to write down a couple of problems and try them on your own. Write this problem down, pause the video, solve it. You may use your math composition book to do this, and then come back to the video and see if you were correct. Okay, here's hoping that you completed the steps in order, and the first step would have been to rewrite this problem standing up. Second step would be to check your denominators and make sure they're the same. Both of these denominators are the same. Both of them are 3. Third step would be to add your fractions, your numerators, not the denominators. So 2 plus 1 is 3. Denominator will stay the same, 3. Fourth step would be to add your whole numbers, 5 plus 3, which is 8. The fifth step would be to regroup if necessary. Looking at your fraction, you have 3. It takes 3 to make a whole, and you have 3. Therefore, you have 1 whole. So if you look at this as a division problem, 3 divided by 3 equals 1. There will be no leftovers, so we'll get rid of the 3/3, turn that into a 1. And then to consolidate our problem, finally we're going to group our whole numbers together, 8 plus 1, which equals 9. You might include that as a 6th step. That's something we don't want to forget to do. If you got 9, give yourself a pat on the back and get ready for the next one. Here's your next problem. Please pause the video, solve on your own, come back to the video and see how you did. Alright, congratulations on completing it. Step 1, I hope you rewrote this problem standing up. Step 2, check your denominators, make sure they're the same. Again, they'll all be the same here today, but we need to get in the habit of checking that. Both denominators are 8, we're okay. Third step, add our fractions together, but not the denominators, only the numerators. So we're adding 6 plus 1, which is 7. Denominator will always stay the same. Step 4, add your whole numbers, 3 plus 1, which equals 4. Step 5, regroup if necessary. Looking at this fraction 7/8, it takes 8 to make an entire pizza. I only have 7 pieces, therefore I do not have 1 whole pizza. Therefore this fraction does not need to be regrouped. So we are now finished with this problem. Again, give yourself another pat on the back if you got this one correct.